Hello everyone, welcome back to the channel. Today we are going to understand microservice architecture. We will answer four simple questions. What are microservices? Why do companies like Netflix, Amazon and Uber use them? Why are so popular with Spring Boot and Java? And how does a microservice architecture actually work? Let's get started. Monolithic versus microservice analogy. Imagine you own a small restaurant. One person takes the order, cooks the food, prepares the bill, and serves the customer. Everything depends on one person. If the person becomes unavailable, the entire restaurant stops working. This is exactly how a monolithic application works. Now imagine a large restaurant. One team takes order, another team prepares food, another team handles billing, another team manages deliveries. Each team works independently. Even if the billing counter has a problem, the kitchen can continue preparing food. This concept behind microservices. Instead of building one huge application, we divide into independent small independent services where each service performs one business function. What are microservices? A microservices is a small independent application responsible for one business capability. Let's take an online shopping application as an example. Instead of one large application, we create separate services such as user service, product service, order service, payment service, inventory service, and notification service. Each service has its own business logic, can be developed independently, it has its own database, can be tested independently, can be deployed independently, can be scaled independently. This make enterprises application much easier to build, maintain, and enhance. So, why do Netflix, Amazon use microservice? The simple answer is scale and reliability. Think about Netflix. Millions of users stream videos every minute. The video streaming service receives far more traffic than the user profile or other recommendation services. Instead of scaling the entire application, Netflix scale only the video streaming service. Similarly, Amazon follows the same approach. During Black Friday, order and payment service receive massive traffic while review or wishlist service don't. Amazon scales only the busy service, saving infrastructure costs. This isolation makes the platform more reliable. That's why large organizations prefer microservices. Then, why is Spring so popular for microservices? Java has been backbone for enterprise software for decades because it's stable, secure, and highly perform. Spring Boot makes building microservices incredibly simple. Instead of spending hours configuring application, developers can focus on business logic. Spring Boot provides easy REST API development, dependency injection, Spring Boot JPA, Spring Security, Spring Boot or API Gateway, service discovery, health monitoring through Spring Boot Actuator, integration with Kafka, Redis, Docker, Kubernetes, and Prometheus and Grafana. Based off this powerful ecosystem, Spring Boot has become the industry standard for Java-based microservices. How do microservices communicate? Each service run independently. They need to communicate it. There are two common approaches. One is synchronous communication. So, for example, order service calls payment service. Then order service calls inventory service. The caller wants for each response before continuing. For this approach is simple but creates tighter coupling. This communication is synchronous communication. The another communication is asynchronous. This uses Kafka and or RabbitMQ. Kafka is very popular. Order service publishes an order created event. Inventory service reserves stock. Notification service sends an email. So, analytic service updates reports. All these services work independently without waiting for each other. This approach improves scalability and resilience. So, this is asynchronous communication. Common components for microservice architecture. A typical microservice architecture contains several components. API gateway acts as a single entry point for routing, authentication, rate limiting, request response transformation. Service discovery. The servers register themselves so other service can locate them dynamically. Spring Reka or Kubernetes DNS is commonly used. Database per service. Each microservice owns its own database. This prevents tight coupling and allows service to evolve independently. Observability. Common tools includes Prometheus for metrics, Grafana for dashboards, ELK Stack for centralized logging, OpenTelemetry and Gagger for distributed tracing. These tools help identify and troubleshoot issues. Benefits and challenges. Benefits: independent deployment, independent scaling, faster feature delivery, better fault isolation, high availability, easier maintenance, technology flexibility. Challenges: distributed transaction, data consistency, network latency, monitoring many services. These challenges can be addressed using patterns like Saga, Circuit Breaker, Retry, and Event Driven Architecture. Conclusion: to summarize, a microservice architecture breaks a large application into a small, independent services. Each has its own responsibility, database deployment lifecycle, scaling. This enables organization to build applications that are scalable, resilient, and easier to maintain. That's why companies like Netflix, Amazon, Uber, and many other enterprise organizations have adopted microservices. Why Springboot has become preferred framework for Java developers building modern cloud native application. This is about microservice architecture shortly. If you found this video helpful, please like and comment for any further questions. Thanks for watching. I will see you in next video.